Hello everyone. So after a general introduction about the blood and its components, let's get into a very important topic, not only for a NEET exam, but throughout your life. If you're going to get into medicine, then you need to have a great understanding about blood grouping, its transfusion, what type of blood group can be given to what type of patient. So it is a vast topic, but it is going to revolve around one basic principle. And that principle is what is discussed in an NCERT, and that is what I'm also going to discuss with some no routine examples. I'm just going to give now. First thing, before getting into all your NCERT details, like it has got A group, B group, O group, and all antigen, antibody, and all that, you might be a little bit confused, like why A blood group is containing what antibody, what antigen, and all, right? Understand it revolves around a great physiologist law, that is Landsteiners law. If you get this law, if you understand what this guy is actually trying to tell, you need not study this at all, because he has given it as simple as possible that anybody can understand. What he has told actually is, now you all know in our RBC we have either A antigen or B antigen, or we have got no antigen. That is what we just put it as a void. Instead of putting it as void, we put it as O, right? Void, zero, no antigen. And you all know that for any antigen that is being introduced or it is present in our body or our immune system is going to compete with it, and it is going to produce a powerful substance. What is that powerful substance called? Antibodies. These are basically proteins, and majority of the antibodies are going to belong to a class of proteins called immunoglobulins, right? So these are some basic things that I hope you already know. If not, it is also fine. Just as of now, if you are a typical 11th standard student and I do not know anything about antigen, antibody, or what you're talking about so far, just understand that an antigen is a foreign substance or an outside substance. If that enters into a body, our body is going to produce some proteinaceous substance which can destroy this antigen, and that is called as an antibody. If you know this, I'm very happy. Now, and this Landsteiner, he had given two laws. The first law is, we'll just get into RBCs directly. If an RBC, right, contains an antigen, okay, if an antigen is present, let me put as antigen positive, okay, which means what? If a surface of RBC contains a particular antigen, then its corresponding antibody is going to be absent in the plasma. Please make a note, this antigen is going to be attached with a particle. Right? If I say antigen in terms of a bacterial or viral infection, it is going to be associated with that bacteria or the virus. I'm talking about RBC. RBC meaning it is going to be in the cell, right? Surface of the cell. Antibodies are always in the plasma. Okay, so antibodies are produced into the bloodstream, so they are going to be in the plasma. So if a surface of an RBC contains a particular antigen, right? So this is with respect to RBCs, then its corresponding antibodies are negative or absent in the plasma. What I am trying to convey, or what Landsteiner is trying to convey, a man, say suppose you have got A antigen in your RBC, which means what is the corresponding antibody of A? It is going to be anti-A. Just remember like this. Okay, A means corresponding antibody anti-A. B means its corresponding antibody is going to be anti-B. So if you have A antigen in your RBC, which means your anti-A antibodies are absent, which means what? They are not present in your plasma. Few might wonder, why is this so? Because just now I told you, when I have an antibody for a particular antigen, this can destroy them, this can kill them, this can remove them. It can do what kind of good things, it will assume that removing this is good, but it is not good in case of an RBC, right? So if A is present, anti-A should not be present, right? It's like you are going as a couple somewhere, okay? Then either your parents or your ex-girlfriend or boyfriend should not be there, right? Then it is a big issue, right? Same thing, yeah. Now, the second law is if an antigen is absent in an RBC, then its corresponding antibody is positive in the plasma. This might sound bit weird, right? இல்லாததுக்கு எதுக்கு ஒன்று இருக்கணும் அப்படின்ற மாதிரி if I say it in Tamil அதுதான் இல்லாததுக்கு எதுக்கு ஒன்று இருக்கணும்ன்ற மாதிரி for something that does not exist why something has to be there, right? That must be your doubt, but let us try to understand this. Let us take this example itself. When I say an RBC is containing A antigen, right, which means what? It is obviously understood that B antigen is not there. Okay. Now, since this B antigen is negative, its corresponding antibody, that is, anti B antibodies, are present in the plasma. Again, you might have, why should I have anti B antibodies in my plasma? For which you need to understand blood transfusion reaction. According to blood transfusion reactions, it is said that if suppose a patient comes to you with a A blood group, he has met some serious accident, he has lost some liters of blood and you need to replace the blood, you need to search for a donor with only that corresponding blood group. If he comes with A blood group, you should go for A blood group antigen, not a B blood group. Why is it so? Because a patient with A blood group will have anti-B antibodies. If I choose a donor as B blood group, it is of no use because my donor's blood RBC contains B antigen that will be precipitated by the anti-B antibodies present in the plasma. So no use. It is why you might ask why there is a need for doing a blood group testing in your license, especially. The purpose of taking a blood group is suppose you meet with an RTA, right? And you know your purse accidentally falls, and the person who tries to recover you is getting your license, and that will be handed over to the police or to the hospital administration, and they will immediately arrange for the blood. That is the most important idea behind getting your details inside the license, especially blood group, right? So this thing of giving a wrong blood group and that is going to react with the antibodies present in the plasma, this I call it as cross matching. This is not needed, but I'm just trying to give you an idea of what it is. So if you had understood this concept, the table that your NCRT gives is going to be very simple for you. And that is what might come for your exam. There's one more important question that I'll talk about. Just quickly to just tabulate the diagram, the table, sorry. Let me have donor blood group, antigen in the RBC, antibody in the plasma. Sorry, this should not be donor. Let us have it as patient's blood group. Okay. And here I'm having donor. Now, if suppose a patient comes with an A blood group, he will have obviously A antigen. And what is the antibody that can be present? According to Landsteiners first law, anti-A cannot be present. According to Landsteiners second law, anti-B can be present. Then donor can be either A blood group or O blood group. Next, coming on to, if a patient has B blood group, antigen will be B, antibody will be anti-A, donor can be B and O. Now, if a patient comes with AB, he will have both antigen A and antigen B. Then only Landsteiners first law will be valid here, where he says if an antigen is present, its corresponding antibody must be absent, right? So no antibodies. So this person, lucky fellow, if he is having AB blood group, he can receive blood from anybody, because whatever antigen I give, he does not have any antibodies, right? So there is no concept of cross matching or some kind of a serious reaction. Lucky fellow, right? So that is why AB blood group patients are called as universal recipients, because they can accept from anybody. Now, O blood group, which means what? No antigen. So he will have both antibodies. So for this guy, I need to give only O blood group. So that is why he is called as universal donor. Because if you take, he can donate blood to anybody, but he cannot accept blood from someone. So pity, right? AB are most luckiest persons. So if you take this table, everywhere I tried to mention Landsteiner. So if you have got those two laws, you can easily fill this table, right? So this is about your ABO blood grouping. Now, talking about RH blood grouping. So what happens with RH blood grouping is, let's see what happens with RH. So what happens with RH is, now our blood group will have something called as positive negative, right? Is A positive, A negative, B positive, B negative. So it contains a second entity that is either positive or negative. That is called as RH factor. So this factor is found in monkeys, right? Since we say we come from monkeys, so we have this factor inherited along with us. So if a person contains this RH factor, then he is said to be RH positive. So I add the ABO blood grouping along with whether I mention whether he is RH positive or negative. If he is not possessing this, then I call it as RH negative. Now, why are we so particular about this RH factor? Is we have got a serious clinical complication, something called as erythroblastosis fetalis. Now, let us try to understand this based on RH factor itself. Before getting into erythroblastosis fetalis, this RH has to be matched even for blood transfusion. I have in the above ABO blood grouping, we have just told an A blood group person can receive blood only from an A blood group person. I have not mentioned about RH factor. You need to look in for even RH factor. That is very important. Let us try to see what happens. Now, an RH positive person, which means what, he has got RH antigen, will not have RH antibody. So let me write this RH antibody negative. Similarly, RH negative person who does not possess any RH antigens will have antibodies in his plasma. If I try to administer, listen carefully, if I give an RH positive blood, if I give an RH positive blood to an RH negative person, first case, I give an RH positive blood to an RH negative person. Just think what will happen. This donor has RH antigen in his RBCs, and recipient has got corresponding antibodies in plasma. So what will happen? This RH factor will react with the antibodies in the recipient's blood to lead on to some serious complications. So RH positive blood cannot be transfused to Rh negative persons, because of the reason that Rh antigen can induce an immune response in the recipient's body because of presence of antibodies. But the vice versa is possible. I can administer an Rh negative blood to an Rh positive person, but this is not possible. Now, every time you cannot remember this, right? All these are some facts that you might tend to forget if you memorize. So for all these, you need to have a clear-cut understanding of Landsteiners law. So if you just know the Landsteiners law, you can solve any kind of questions that comes from ABO blood grouping and RH blood grouping, right? Now, when RH factors are not matching, I call it as RH incompatibility. So when such, suppose I give an RH positive blood to RH negative individual, there are some complications, and all that I collectively call it as RH incompatibility. So that special case that happens with pregnant ladies and the fetus is what is called as erythroblastosis fetalis. So erythroblast refers to RBC, right? So erythroblastosis is destruction of RBCs. Where destruction of RBCs is going to happen in the fetus. So destruction of RBCs in fetus due to RH incompatibility is called as erythroblastosis fetalis. Now we will see what happens. I'm going to give you a typical NCRT example explanation. Now I've got RH negative mother. Just imagine Rh negative mother. So which means what? This Rh negative mother, she has all the no materials available for production of Rh antibodies. Right? When I say in the plasma she has antibodies, does not mean the antibodies are flowing. Okay. Once the antigen is getting exposed, these antibodies will be activated. So all these will be in an inactive form. It will be hidden somewhere. Once the antigen comes, all these will be activated. So Rh negative mother, she has got some antibodies that keep circulating in the blood. It is in inactive state. Once it is exposed to Rh antigen, then it will show its action. Okay. So there is Rh negative mother, and imagine that the fetus developing is Rh positive. Right? Let us say the Rh factor has come from the fetus father, so the fetus is becoming Rh positive. Now, this antibodies that is in the mother cannot get into the fetus, right? So during the first pregnancy, the fetus is going to be normal. Why the fetus will be normal? Because the mother and the fetus are well separated by the placenta. So as I said, unless and until the mother gets activated by the Rh antigen, this antibodies has no role. Please take this point clear. Right? So during the first pregnancy, the fetus and the mother are well separated by the placenta, so there is no chance that the Rh antigens can get exposed to the mother's blood. Right? So first fetus is very safe, very safe. Now, say suppose the same mother is planning for second pregnancy, and unfortunately, even the second fetus is Rh positive. The second fetus is also Rh positive. But this time, okay, let us assume that after the first pregnancy, so you all know what is the procedure, right? So there will be a mixture of blood of the fetus and the mother, because the placenta will be also scraped off. So that time some amount of blood can get mixed with the mother's blood. So at the time of delivery, there is a huge possibility that the Rh antigen is getting exposed to the mother's blood. Right? Along with the delivery, this is also happening. So mother has been exposed to Rh antigen. So now what will happen? Our antibodies, Rh antibodies are in the active form. Right? If I want to say it in a Talabari form, Verittanama irukku. Okay, it is in Verittanam. So now what will happen? Pity second fetus, it is also Rh positive. Now the antibodies are in active form. So please understand this concept. The placenta is permeable to antibodies. The placenta is permeable to certain type of antibodies. And one such antibody is Rh antibody. So what will happen now? These antibodies, along with all the nutrients, will enter into the fetus via the placenta. Pity fetus, it is Rh positive, so it has got Rh antigen. These antibodies are in Verithanam, so it will just attack all these fetal RBCs. And if the fetal RBCs are going to be attacked, as a result of RBC destruction, you all know, major symptom is anemia. Along with anemia, there will be jaundice. So, due to Rh incompatibility, if a fetus is suffering from anemia or jaundice, in that condition I call it as erythroblastosis fetalis. Now, they will confuse you with this case history of Rh negative mother, Rh positive mother, and all that. Please be very clear with the concept. So keep revising Landsteiners Law. Try to correlate with Landsteiners Law. So how will you prevent? Since because there is the serious threat, no family cannot, you cannot tell the family not to plan for second pregnancy, right? So you need, as a doctor, you need to do some prophylactic measures, some preventive measures. So what you do is you try to destroy this antigen then and there. So the moment this antigen is exposed, you try to administer some ready-made antibodies. You try to administer ready-made antibodies. So already the plasma contains some antibodies. Along with it, you also give some ready-made antibodies. Immediately you give some antibodies. So the Rh antigen is going to be destroyed then and there. So do not allow it to aggravate. So the second pregnancy will also be safe. So this is about blood grouping. So we have discussed about ABO blood grouping, Landsteiners Law, and then erythroblastosis fetalis. See you in the next video. Thank you all. Bye.